Okay, class, here's another example of calculating resultant of distributed loading. So in our problem, we are tasked to find the magnitude and the location of equivalent resultant force of this loading. So this problem is a fixed supported, meaning you have your reaction along y and your moment. We don't have any reactions along x because our loading is only vertical load. So wala siya horizontal load. So in this example, we have a beam, a fixed beam attached with a loading of trapezoidal loading 50 and 100 pound per foot, and this is 9 feet. So if you're familiar with calculating the centroids or having the points of the centroids of a trapezoid and calculating the area of the trapezoid, you'll get this is a shortcut solution to this problem. So area of the trapezoid is equals to 1/2 h a plus b, right? So just make sure that you assign the value of h appropriately. So 1/2, your h here is 9 and your a is 50 plus your b is 100. So a is equals to 675 pound. And that is equal to your FR, 675 pound. And the resultant is at what point your FR will act from B. So X bar is equal to 1/3 of 2a plus b over a plus b times h. So 1/3 of 2 times 50 plus 100 over 150 times 9. So get your calculator and you will get X bar 4 feet. So that is the location of your FR from D. So that's it. That is the shortest way to solve this problem, and it is if you know the area of the trapezoid and the location of its centroid. But the normal way of solving this problem is that you take its composite loading. So you will have this one. This is 50 pound per foot, and this is 100 pound per foot. So with a trapezoid, you will get this is the beam. Okay, in a trapezoid you will get a rectangle and a triangle. So basically, if you have a triangle and you know let's assume that this is F1 and this is F2. So F1 F1 is, how to solve this F1? This is 9 feet. Okay, so the area of this is 50 times 9 feet is equals to, get your calculator, times 9, 450 pounds. Your F2, you have a triangle, 1/2 BH, diba? 1/2 BH. BH is 1/2 base is equals to 9 feet times your height, 50, since it is 50, so 100. So this one is also 50. So F2 is equals to, get your calculator, 225 pound. So you have F1 and your F2. So when you do summation of all forces, you will get summation of all forces along y must be equal to 0. So you have your reaction. So you have F1 plus F2 is equals to your reaction at here, diba? At B. This is our A. Your BY. And your BY is equals to your FR, right? Therefore, your FR is equals to 450 plus 225 is equals to 675 pound. And this is equal to our first solve here. FR is equal to 675 pounds. So now let's get the Z, X bar, I mean. So when you get X bar, you have to first get the Y bar, X1 bar. X1 bar is equals to, so just the half of 9.9 feet, so you get 9. And X is 1/3 of your L. 1/3 of L is equals to 3. Right? So, but this is not the questions, diba? We are about to find the X bar. Therefore, the location of FR, location of 675 from B. So this is what we ask. So okay, so we will get the summation of all moments at certain point, and in this case we will use at point B must be equal to 0, and our convention is that is a positive. Therefore, summation of moments and our MB, our MB is equals to the FR X bar, right? So we have F1 X1 bar plus F2 X2 bar is equals to FR X bar. So you have 225 3 plus 450 4.5 equals to, this is F1 X1 bar, F2 X2 bar. So this is, and we have FR of 675 X bar. So we have X bar equals to 700 over 675. We have x bar is equals to 4 feet, and that's it. So we have now our solution. Okay, so you get your F1, F2 is equals to your reaction at B1, at B, reaction here. This is BY, and this is BY is equal to the FR. So that is why we have here. And then you sum F1 and F2, you will get your FR. Now to find the location of FR from B, you have to first get the location of F1 and F2. This is simply 1/2 of 9.5, and this is 1/3 of 9. So a summation of moments at B, this must be equal to 0 since our problem is in equilibrium, and your MB is, this is equal to FR x bar, so you will get F1 x1 plus F2 x2 is equals to FR x bar, so your x bar is 4 feet. So that's it. That's our problem for today.